So, hello everyone. My name is Pedro. I'm a third year PhD student at the University of Birmingham. And in this work, we report for the first time the action of heterochrony in a very important group of fossil rocks. But before I tell you how we found this and how we tested this, there are two important subjects I want to introduce to you. So the first one is the study group, baurusuchids. So baurusuchids were a very large fossil rocks that lived during the late Cretaceous of South America. And based on their very peculiar post-cranial and cranial morphology, we can say that they were terrestrial, hypercarnivorous, and top predators of their time. And baurusuchids are included in a broader group called Notosuchia, and they are well known for their huge diversity, not only in terms of species, but also in terms of morphology. And this huge morphological disparity is reflected in their ecology. So for example, we had some species that could be omnivorous, herbivorous, very different from the crops that we have today. And the second important thing is heterochrony. So what is heterochrony? It's the process of shifts in rate and timing of evolution during the development of species. So I think an easy way to explain it is comparing ancestor and descendants. So there are two main types, pedomorphosis and paramorphosis. Only the second one is important for us today. And so when we look at the juveniles in paramorphosis, when you look at the juveniles of the descendants, they look like the adults of the ancestors. So the juveniles of the descendants look older, let's say. And so when we found this very nicely preserved skull of a juvenile of baurusuchid, the first completely preserved of a juvenile, we noted that it looks very similar to adults of other Notosuchians outside baurusuchid. So we thought, there could be some paramorphosis going on there. Alright, so to test this, we used a 2D geometric morphometrics approach, using both dorsal and lateral views of skulls. And our sample was very comprehensive. We sampled a lot of specimens and taxa all across Notosuchia, not only baurusuchids. And trying to summarize our results, after the first PCA, we concluded that paramorphosis is present in the evolution of this group because these two blue dots here are the juvenile baurusuchids, and this blue morphous space here represent the adults. So the juveniles fall outside, they're displaced from the adults, and they're included in the pink one that represents the other Notosuchians. And another cool result that we got was after size correction, so after removing the effect of size in our data, the differences in shape vanished, so they disappeared. So we can see that the blue, again, baurusuchids in blue, they are inside the pink one, the other Notosuchians, morphic space. So after this, we can say that size can explain most of the shape variation that you were seeing before, and so size and shape are coupled. And finally, just to conclude, the first takeaway message that we had is that paramorphosis is present in the evolution of baurusuchids. Second, we can say that size and shape are coupled in this process. And because of this link between size and shape, we can say that heterochrony had an important role in the emergence of hypercarnivory in baurusuchids, because if we think about it, at the same time that these animals got bigger, we also had the emergence of this very peculiar cranial morphology. And that's it. Thank you.